Howdy. Yet another one about water. Scientists identify heat wave at bottom of ocean. The 2013 to 16 marine heat wave, known as the blob, warmed a vast expanse of surface waters across the northern Pacific, disrupting west coast marine ecosystems, depressing salmon returns, and damaging commercial fisheries. It also prompted a wave of research on extreme warming of Earth's ocean surface waters. But, as the new NOAA research shows, marine heat waves also happen deep underwater. In a paper published in the journal Nature Communications, a team led by NOAA researchers used a combination of observations and computer models to generate the first broad assessment of bottom marine heat waves in the productive continental shelf's water surrounding North America. This was a rather long sentence. Researchers have been investigating marine heat waves at the surface for over a decade now, said lead author Dylan Amaya, a research scientist with NOAA Physical Science Laboratory. This is the first time we've been able to really dive deeper in assess how these extreme events unfold along shallow seafloors. Marine heat waves dramatically impact the health of ocean ecosystems around the globe, disrupting the productivity and distribution of organisms as small as plankton and as large as whales. Yeah, because they feed on the plankton. As a result, there has been a considerable effort to study, track, and predict the timing, intensity, duration, and physical drivers of these events. Most of the research has focused on temperature extremes at the ocean surface, for which there are many more high-quality observations taken by satellite ships and buoys. Sea surface temperatures can also be indicators for many physical and biochemical ocean characteristics of sensitive marine ecosystems, making analysis more straightforward. About 90% of the excess heat from global warming has been absorbed by the ocean, which has warmed about 1.5 degree over the past century. So it's not that much. Marine heat waves have become about 50% more frequent over the past decade, or they just had the possibility to measure them. In recent years, scientists have increased efforts to investigate marine heat waves throughout the water column using the limited data available. But previous research didn't target temperature extremes on the ocean bottom along continental shelves, which provide critical habitat for important commercial species like lobsters, scallops, crabs, flounder, cod, and other ground fish. Due to the relative scarcity of bottom water temperature datasets, the scientists used a data product called reanalysis to conduct the assessment, which starts with available observations and employs computer models that simulate ocean currents and the influence of the atmosphere to fill in the blanks. Using a similar technique, NOAA scientists have been able to reconstruct global weather back to the 19th century. Yeah, with a computer model it's probably very easy. It goes where you want to. While ocean reanalysis have been around for a long time, they have now only recently become skillful enough to have high enough resolution to examine ocean features, including bottom temperatures near the coast. Now, I don't know if does it make any sense to read the whole thing through, because it's rather long. But bottom marine heat waves can also occur with little or no evidence of warming at the surface, which has important implications for the management of commercially important fisheries. Yeah, probably on many other things too. That means it can be happening without managers realizing it until the impacts start to show. The groundfish, usually warm bottom water temperatures, have also been linked to the expansion of invasive lionfish along the southeast US. So they are talking basically about fish. But, for example, I've been talking about this West Spitsbergen Current. In the past, I tried to find a video, but I didn't. But I did videos about these. Or this in particular. The West Spitsbergen Current, WSC, is a warm, salty current that runs poleward just west of Spitsbergen, formerly called West Spitsbergen, in the Arctic Ocean. The WSC branches off the Norwegian Atlantic Current in the Norwegian Sea. The WSC is of importance because it drives warm and salty Atlantic water into the interior Arctic. The warm and salty WSC flows north through the eastern side of Fram Strait, while the East Greenland Current flows south through the western side of Fram Strait. The EGC, the East Greenland Current, is characterized by being very cold and low in salinity, but above all else it is a major exporter of Arctic sea ice. Thus, the EGC combined with the warm WSC makes the Fram Strait the northernmost ocean area having ice-free conditions throughout the year in all of the global ocean. Svalbard. Somewhere here, I guess, is the seed farm or the seed bunker. And it might have been at the poles once. It looks in a way like a coral reef. And I think the possibility for this West Spitsbergen Current being so warm and salty could be geothermal activity. In other words, it is some kind of volcanic activity. In other words, we have to take fluctuations into account because it is a circuit of Earth. If it diminishes or just gets lower or even much more hotter than ever, an eruption in a way, we probably will notice the effects also in the weather patterns. And the same thing is for the other current which goes southwards, which is very cold. It could also be geothermal activity just on the other side of the spectrum. And parts of that sea are rather deep, and I don't remember now the exact amount of water which somehow needs to be on top of a volcano. When it erupts a little bit, there is no sign on the surface visible. But of course, down deep below there could be heat, a heat wave, because there's something going on, erupting on the sea floor, like let's say 7,000 meters below the surface. Probably there's not too many signs on the surface from, let's say, an average volcanic eruption. If it would be a big one like Tonga, we probably would notice it. But let's say just in the last 200, 400, 500 years, it was like rather easy on Earth because there hasn't been any too big volcanic eruptions until Tonga. So the times might be different in the future. The past is not always the key to the future. Or it is, but it depends on how much you take into account. That's probably more correct to say it like that. But anyway, I just wanted to point this out, that we have hot currents or warm currents emerging from somewhere. It is not the wind or the sun which makes this warm current. But anyway, I leave it here. Thanks. Bye.